Hi there. Here we use partial fractions. So this is equivalent to a over x minus 2, what do we call it, integral of that dx, and the integral of b over x minus 4 dx. A and b are minus a half and a half respectively. So now we can write this as minus the integral minus a half over x minus 2 dx, add a half over x minus 4 dx. Which gives us minus a half ln just as x minus 2, add a half ln x minus 4. Now this simplifies to give us a half ln 2 minus a half ln 4. Applying the law of logarithms, we have this simplified fully as a half ln a half. Now this is evaluating it at the limit 6, so I should enclose that here. This is at 6. Now the same thing, we evaluating at the limit 5, and then we'll subtract 5 from 6. So this turns out to be a half minus a half ln 3 add half ln 1. Simplified will give us a half ln 1 over 3. Now, putting this all together, we have this is equivalent or evaluated at a half ln a half minus a half ln a third. Again, applying the law of logarithms, we have this written as a half ln a half over a third. Remove this there, which finally is a half ln 3 over 2. So first, before evaluating this logarithm, I applied partial fractions to find the constants a and b, a being negative a half, b positive a half. Then we applied the limits for 6, and this was the result, and the limits at 5, which gives us this, simplified as a half ln 3 over 2. Thanks for watching. I'm Alistair.
Hello. Factorise and evaluate this expression. Here we have a difference of 2 squares. So we can write this, factorise it as 7 3/4 add 2 1/4, multiply this by 7 3/4 minus 2 1/4. Now this 7 add 2 is 9, and 3/4 add 1/4 is 1, so this evaluates to 10. And we have 7 3/4 take away 2 1/4. We'll have 5 from taking away 2 from 7. and 3/4 take away a quarter, we're left with a half, so that's 5.5. So we have 10 times 5 to 10, 11 over 2, which gives us 55. Next we have 8.5 squared minus 1.5 squared. Again, difference of two squares. So we have 8.5 added to 1.5, and we multiply this by the difference, 8.5 minus 1.5. This gives us 8, add 1, which is 9, add the 2 halves, which gives us 10, and this gives us 8 take away 1, which is 7, a half take away a half is 0. So this evaluates to 70, all without the use of a calculator. What about this one? We have decimals, but the same applies to the difference of two squares. So we have 5.25 add to 4.75, and we multiply that by the difference, 5.25 minus 4.75. Let's just write that again so you can see all of it. 5.25 added to 4.75 and 5.25 take away 4.75. Right, this evaluates to 10, so we have 5 and 4 and 9, and neglect the 0.25 and 0.75 gives us a whole. So this is actually 10. Now 5.25 take away 4.75 will just leave us with a half, or 0.5. And this evaluates to 5. No need to use a calculator. Just factorise and evaluate. Thanks for watching. I'm Alistair. Bye for now. Hello. Evaluate using indices. Let's do the first 16x to the 4th. And we're taking the square root. Whenever you see the index a half, that means the square root. And this is equal to we square root 16 and also x to the 4th. Take the square root of 16, it's 4. And if we clear the brackets here by multiplying indices, we'll have x squared. So this evaluates to 4x squared. Next we have 4/9, and we take in the power of 3 over 2. Now we can write this as 4/9. Let's put in the brackets here. It's raised to half here, and then at the end, outer brackets, we have cube. When we clear this, we'll get back to 3 over 2. So first it's asking us to take the square root of 4/9, which means the square root of the numerator and the square root of the denominator. We get that result, we cube it. And this is equal to 2 over 3. And we cube the result, which gives us 8. 2 cube is 8 over 3 cube is 27. So that's our result. Now the last one, 2 raised to a negative 1 to the fourth power times 4 to the third power of cubed. This is equal, you can write this as a half, and this is raised to the fourth power times 4 to the 3. That means 1 to the fourth power over 2 to the fourth power times 4 cubed. This is 1 to the fourth power is 1, and this becomes 1 over 16 times 4 to the third power. From here, we can write that 4 squared is the same as 16, so we can rewrite this as 1 over 4 squared times 4 to the third, so 4 cubed. The reason I'm trying, I use this as an equivalent to 16 because I'm looking for something with the same base as this 4 cubed, so that I can evaluate this without much of a calculation. Now I'll take this into the numerator, and now this becomes 4 raised to minus 2, and we're multiplying this by 4 cubed. We apply the law of indices, which indicates that we can add indices because the bases are the same. So this becomes 4 to minus 2 add 3, 4 to 1, which is 4. So this evaluates to 4. Thanks for watching. I'm Alistair. Bye for now. Evaluate without the use of a calculator. 125 raised to 2/3 power. Let's start with that one. So 125 raised to 2/3. The denominator will indicate the root. So this is indicating that it's 125 raised to the 1/3, and then we square the result. So the cube root of 125, we can write that cube root 125, and then all of that is squared. So cube root of 125 is actually 5, and we square that, we get 25. Next we have 32 raised to the power 3 over 2. This gives us, again, 32 to the half. That's the square root of 32, and then we cube it. If we take this as written as square root of 32 cube, we can decompose this into square root of 16 times the square root of 2, and all of this cubed, which gives us 4 root 2, and we cube that. Well, 4 times 4 is 16, times 4 is 64. Root 2 times root 2 is 2, and then times another root 2 is 2 root 2. So we have 2 root 2. This evaluates to 128 root 2. Next we have 81 raised to 3/4. This is equal to 81, so 4th root cubed. You can write as 4th root 81, and we'll cube the result. The 4th root of 81 is 4, and when we cube 3, my mistake, 3, And when we take the cube of 3, we have 27. Next we have 16 raised to 5 over 4. This equals 16. The fourth root of 16 raised to the fifth power. The fourth root of 16 is 2. And 2 raised to the fifth power is 32. And next we have 64 raised to the 5/6. This is the same as 64 raised to the 6th power. And raise that to the 5th power. The 6th root of 64 is 2, and 2 raised to the 5th power is 32. And finally, 1,000 raised to 2/3 is equal to 1,000 cube root, square that result. Cube root of 1,000 is 10. And we square 10 to get 100. All of this done without the use of a calculator. Very useful skills to develop for any sort of calculations throughout your studies. Thanks for watching this video. Bye for now. Hi, we're asked to evaluate these expressions by factorizing. No use of a calculator here. It depends on a concept called the difference of two squares. And by that I mean what I'll show you in a minute. Difference of two squares. So if we have the expression x add y times x minus y, we expand this via x squared minus xy add xy minus y squared, leaving us with x squared minus y squared. So conversely, if we have x squared, if we're given something in this form x squared minus y squared, we can factorize it as x add y x times x minus y. And this is the concept of difference of two squares. Now let's look at our problems we have. We have 96 squared minus 4 squared. We can factorize this as 96 minus 4 brackets times 96 add 4. And this gives us 92 times 100, 9200, or 9,200. The second one is 88 squared minus 12 squared is equal to 88 add 12 times 88 minus 12. This is 100 times 76 gives us 7,600. What about the last one? We have 225 minus 8 squared. Well, 225 is not in the format that we have for the others. And 225 is actually 15 squared. So we can write this as 15 squared minus 8 squared. And if we factorize this, we have 15 add 8 times 15 minus 8. This gives us 23 times 7, which gives us 161. So next time you have a calculation of this format where you have a difference of two squares, don't reach out for your calculator yet. Just factorise and the calculation will be a lot easier. Thanks for watching. I'm Alistair. Bye for now.